Hello, everyone. Welcome to InfinStore's latest live webinar, HIPAA Compliance for AI Data using InfinStor MLflow. So in today's event, we will showcase how to implement a HIPAA compliant AI platform using our InfinStor MLflow service. And there will also be a Q&A session at the end, along with more information about our company. So thank you for joining us, and please welcome InfinStor CEO Jagain.
Good morning, folks. My name is Jagain Sundar. I'm with InfinStor. Thank you for attending our webinar. Today's title is HIPAA Compliance for AI Data using InfinStor MLflow. We'll start with a primer on MLflow. We'll get into details of HIPAA compliance and specifically HIPAA best practices. And finally, we'll finish up with some details on the enterprise MLflow offering that InfinStor offers. MLflow is AI industry's most popular experiment tracking and model management system. It is an open source project that was initially built by Databricks and Azure ML, but has been widely adopted by a large part of the industry. A number of huge customers like Zillow and Facebook and Booking use it as an integral part of their day-to-day business. It supports most popular AI frameworks such as PyTorch, TensorFlow, and it's also very friendly with Amazon SageMaker, Azure Machine Learning. It has been well awarded. It won the 2021 BOTY Award and came second in the Kaggle survey on tracking systems. There are three main parts to MLflow. There's the experiment tracking part, which tracks experiment runs and inference runs. It's not just the data scientist's work that's recorded here. You can use it to record data engineers' work as well. Then there's the projects part of MLflow, which is a way to package ML code such that you can reproducibly use that packaged code. This is somewhat like a Git repository for traditional software source code, but this includes more capabilities for the AI industry. Finally, there is a way to store models, to version, to deploy and manage models in MLflow called the MLflow models subsystem. Let's take a look at experiment tracking. It is useful for tracking experiments both by data scientists and the inference runs that data engineers use. For the data scientist, it really serves as the equivalent to the lab notebook. One of the things that you have to understand is that when an industry moves from a traditional wet lab type chemistry experiment for drug discovery to say AI-based drug discovery, a lot of the regulatory requirements actually still apply. You may need to be able to prove how you came up with the model. And the best way to do that is to track all your experiment runs using a system such as MLflow's experiment tracking system. Therefore, the experiment tracking system in MLflow, which integrates really well with things like TensorFlow and PyTorch, is a critical component of most industry AI users. MLflow projects is the ability to package AI code into reusable units. You can use it as part of directed acyclic graph or DAG computation, pipelines, whatever. It also saves the environment for that code to run, mostly by means of a Conda environment or a Docker file environment. The reproducibility of AI projects has always been a challenge. With this method, you can guarantee that a project can be reproduced, whether it's a training run or whether it's a inference run or a retraining run. Finally, the model registry is one of the most popular pieces of functionality in MLflow. You can use it to store models, to version models, track lineage, what experiment run, using what data produced the model, put models into various stages, staging, production, archived, or if you put a model into production and the version of the model doesn't work well, you can roll back. That sort of capabilities are extremely useful as well. So that's a brief introduction to MLflow. Let's move on to looking at HIPAA. This is a government regulation, a pretty good regulation actually. And the essence of it is that entities, software entities or healthcare providers or healthcare data management companies must protect against reasonably anticipated threats to the security or integrity of the information. While this sounds a little bit vague, what has really become best practice is the following. You need authorization and access controls for the data. You need audit controls to make sure that any access or failed, or whether it's a failed or successful attempt to access the data, is audited. Data integrity must be guaranteed. The data cannot be changed. The data cannot be altered or corrupted in any way. Data must be encrypted in motion and at rest. Availability of the data is very important, and that comes under the category of high availability, disaster recovery, and data backup. So let's start with looking at authorization and access controls for both raw data and intermediate data, and seeing how MLflow, InfinStore's enterprise MLflow offering, can help you with those problems. Let's take an example flow. This is a hypothetical example, but it's very close to something we worked with a specific customer for. So it's more real than not. Let's consider a data working its way through an example AI system and the HIPAA technical safeguards therein. The example we've taken here is medical image processing, determine from a CT scan whether a patient has heart disease or not. Start with the data, CT scan images from various CT scan machine types, Philips, GE, whatever. The data is first anonymized. Now, this is a very interesting aspect of the system that we are going to consider in a little bit of detail. Next step is the image conversion from DICOM to NIFTY. As it turns out, DICOM is the image format that most of these CT scan machines write it out in. That consists of multiple images, basically each slice of the human body as it goes through the CT scan machine. They're converted to something called the NIFTY format for processing in the AI system. You first do training of some labeled data to produce model. Model is stored in the MLflow model registry, and then it's going to be used for inference. What does the inference pipeline look like? You also start with anonymization, then you feed it to a DICOM to NIFTY conversion system, and then you finally use the model to infer results for that particular image. So the overall pipelines look like this. The blue pipeline is for the training, and the green pipeline is for inference. Now, the data that is subject to HIPAA is a very interesting consideration here. The most naive approach would be to say, if we anonymize, after the anonymization, the data is not subject to HIPAA considerations. This is an interesting aspect, but and there's certain implications already. It means that if you have authorization and access control, the pre-anonymization data should be tightly controlled, whereas the post-anonymization data can be opened up a little bit more. There are two things that we need to consider here. The first thing is de-identification of protected health information, PHI data, may render it useless. For example, a pipeline may have different models for different age group patients. Let's say you're trying to determine if the patient has heart disease. You know that the data scientists have come up with a model saying for patients up to 35 years of age, this model works really well. Patients over 35 years of age till 60, this second model works better. And for patients over 60 years of age, you need this third type of model. Now, once anonymized, part of the identification of PHI data, according to regulations, requires that age data be removed from in the anonymization process. I mean, this was well intentioned because it protects against age discrimination. On the other hand, we are using the age for a very useful purpose here to determine which model to use. So the end result is that if you have such a sophisticated AI pipeline, you may not want to anonymize completely to the standards required by regulation, but you may want to control access, because at that point, the anonymized DICOM to NIFTY and infer all stages have access to PHI data, and they must be access controlled very tightly to ensure that people don't access data that they're not authorized to access. What is the implication of this? Fine-grained access control to data is required. What's included with cloud systems such as Amazon S3 is basically coarse access control. It's S3 based, you specify a path and you have access control to that. That's it. You need much, much more than that. In addition to input data from S3 bucket, intermediate data produced in AI pipelines must be controlled. Access to this data must be controlled in a manner that's consistent with regulatory requirements. And that's exactly the capability that InfinStor MLflow offers. So let's look at this from the perspective of InfinStore's capabilities. We have access control, data retention, and data selection capabilities, each of which I will go into some detail. So our access control system is very logically designed. It's based on corporate directory. So if you have Active Directory in your corporation, or if you use Google OAuth, or if you use Auth0 or some other service provider, we will connect to that access control system and we will use that database. So InfinStor MLflow does not keep its own database of users. This guarantees that there's only one user, and if an employee leaves the company and you remove that user from the corporate directory, that user has no longer got any access to InfinStor MLflow. There's no question of synchronizing users or synchronizing groups or falling out of synchronization. All of those problems are eliminated. There's also no question of creating cloud-based IAM users or any such users to allow access to cloud resources. There are 3 roles for users: readers, editors, and managers. We'll go into more detail in that. And you have to authorize users for access to experiments and models. Data retention is accomplished by means of InfinSnap technology. We'll go into some detail on that. And the requirements, HIPAA requirements of data integrity, that's no possibility of altering or deleting data, is accomplished with InfinSnap. Data selection is another capability that we'll talk about, and we have the ability to do data selection by time or metadata, both of which are very useful for AI pipelines. Let's take a look at access control first. As I mentioned, we are very intent on connecting to your corporate directory, Active Directory most often. Sometimes there are other systems as well, such as SiteMinder or Google OAuth. This implies that you don't need to create IAM users for access to S3 data. So a user who logs into his InfinStor MLflow system using their corporate credentials will be allowed to access exactly the data they're allowed to access. And there is no question of having a mirror IAM user or some such construct that's prone to errors and likely to cause security breaches. The roles that we support for users are reader, editor, and manager. And these roles permissions are applied to the protected entities, MLflow experiments and MLflow models. This is a very interesting concept, because one of the things that is necessary for people to pay attention to is access to models must also be restricted and managed. In case there is some way to reverse engineer such that you can take a model and infer something about the data that was used for training, it's very important to ensure that models are also controlled access. Let's take a look at the data retention capabilities that InfinStor MLflow offers. We have a proprietary technology called InfinSnap, which is a snapshot of data. What this does is that at the beginning of any training or inference run, we will take a snapshot of the data and record the snapshot in the experiment run as a parameter. What this means is that that data is immutable. Even if somebody were to come along to the S3 bucket and delete that data, at the time of inference, whatever data was available is perpetually available. It satisfies the need of HIPAA data retention policy perfectly. You have to remember that Amazon S3 itself includes a object level data retention mechanism called versioning. However, most AI pipelines use a directory full of objects or thousands of directories full of objects. In that case, object level versioning is inadequate for proving data retention. A snapshot capability like ours is the only way to prove that you have retained all the data that was used in the inference or used in the training. So data selection. So this is not really a HIPAA requirement, but it's a very useful feature that we offer in order for you to build interesting pipelines. You can choose a slice of data from a begin time to an end time, and that's called infant slice in our proprietary terminology. And it's quite hard to do so without InfinStor. If you go directly to an S3 storage system and ask it a question like, give me all the data that was ingested between 9 a.m. and 10 a.m. this morning, for a large bucket, that's a very hard question to answer. We solve that problem in a very efficient manner. Second, metadata. Files such as DICOM, which is the image file that's output by CT scan machines, contain a lot of interesting metadata that may be utilized for the AI pipeline. You may want to have different models based on the gender of the patient, based on whether the patient is a smoker or non-smoker, age of the patient. These are all interesting things to use, and we offer that capability as part of our API into our system. Audit controls for data access and for processing activity. These are built into our system. InfinStor MLflow is a unique system where we have the ability to track experiments and inference runs, manage models. We also have connection directly into the storage. So we have an ability to offer an audit trail of all attempts to access the AI data, whether it was successful or not. Intermediate data is also tracked in this manner. The utility of this is obvious from my earlier comment on how if you fully anonymize data, it may not produce useful results. So you may need to keep some parts of it in PHI sensitive manner and continue to manage access control to that. This will audit that particular access, so you can guarantee that you have a track record of anyone who tried to access the data. Finally, let's take a look at high availability, disaster recovery, and backup capabilities of the AI system. This is important because HIPAA requirements state that the data must be available, must not be modified, and disaster recovery, high availability, and backup are an important part of that equation. So here's a simplified architecture look at our architecture. We are based on a serverless compute engine that's AWS Lambda and DynamoDB. And we have CloudFront distributions in front of our system. That ensures that we can make our system available even in the case of a single availability zone failing. In simplified terms, an availability zone represents a data center and a region represents a particular location. So Amazon may have US East 1, which is in Virginia, and they may have 10 different data center buildings. Each of those data center buildings or cluster of buildings represent an availability zone. The way we set up our system is that the Lambdas are running in 3 availability zones, 3 data centers, and the DynamoDB instance also has a footprint in 3 availability zones or data centers. So if a single data center goes down, it's of absolutely no consequence at all. There is no data loss and there is no downtime. The service will continue to operate. This fully satisfies the requirement of high availability. Just to refresh, high availability refers to the availability of data and compute services within a region. If a single data center fails, the system should continue to be up. That's what high availability offers. We have CloudFront distributions in front of the S3 bucket that holds the static content, and CloudFront is very resilient to availability zone failure. As I mentioned, we are a serverless architecture and deployed in 3 availability zones, no loss of data, no downtime, and there's no operator action necessary. This is completely automated and hidden from operational administrative actions. Let's take a look at our disaster recovery capabilities. We deploy in a primary region and we configure the DynamoDB table to have a replica in a backup region. And DynamoDB offers this capability called global table replication, which is a multi-master system. And in the primary, when the primary region is up, primary region is master and it continues to back up to the backup region. Let's say that the primary region goes down, flood, earthquake, whatever, the whole region, the whole location is out. What happens is that at this point, we bring up the lambdas in the backup region, the cloud fronts and the DNS entries are changed, and the service comes back up running in the backup region with minimal loss of data. You have to remember that this requires operator action. There is a set of scripts that we offer for this to be enabled, and that's when the backup region will be up. For fail back, to go back to the primary region, also there's a need for operator action. About 15 minutes of downtime is expected. Minimal loss of data. Data is not 15 minutes worth of data is not lost. It's just the last parts of the transaction log that were not transferred over. That's the only piece that is lost. Finally, encryption. Let's consider that for both at rest and in motion. The service uses the highest grade encryption certificates from a real certificate authority. There are no self-signed certificates anywhere in our system, and they're all based on real DNS entries. It is not even possible to configure our system without encryption for tested development. We want to ensure that it is always tested and developed in the most secure fashion so that deployment in production is also up to that standard. The data is also encrypted at rest. So I would like to come to the last section of our webinar today, where we have considerations for enterprise license. So this is not a software as a service offering. The InfinStor service is installed fully in the customer AWS account, and it operates in the customer's account on customer's data and customer's compute facilities, thereby ensuring that HIPAA compliance and other regulatory requirements are easily satisfied. InfinStor staff have no access to the data in the customer's account. Updates and support are actually facilitated by means of a shared desktop or some such facility. There is no call home, and that means that there's no leaking of data, there's no leaking of metadata, nothing of that sort. It is designed for regulatory compliance, HIPAA included. That brings us to the end of my webinar. If we have any questions, I'm happy to answer them now. We have one question here. What does it mean for access controls and no S3 keys to be distributed? So the beauty of our access control is that once the user logs into MLflow using his corporate credentials, access to the S3 data is actually managed by our system. You do not need to ensure that the user's laptop has AWS keys. You don't need to ensure that the cloud VM that the user has those keys. All of those requirements are removed. If the user is authorized to access the experiment or that particular intermediate data, we will generate the capability for that user to access those objects in the S3 storage. This completely removes the need to create IAM users or any such cloud native, but not necessarily enterprise native entities. And that's one of the powers of our system. I have another question here. Can you tell us a little bit more about the metadata capabilities? So this is an interesting patent pending feature we have. At the time that you ingest data into your cloud object store, our system kicks in, looks at it. For example, if it's a DICOM image from a CT scan machine, we extract the metadata, things such as patient's age, patient's gender, smoker, not smoker, and we put it into a DynamoDB database. We can also take this extract such data from the path that the file is stored in. For example, if you're ordering by age, or if you're ordering the files by gender, we can pick up that data from the path also. We put it into our DynamoDB database, and when the user goes to access that data using their system, we have APIs where they can extract that metadata in the form of a pandas data frame. That's where the power of an AI system, where you have different models based on different metadata, is created. The interesting aspect is the metadata can come not only from raw files, but from intermediate processing also. Maybe you have a model that determines the percentage blockage in the artery of the user. You can say this person's arteries are 30% blocked and this other person's arteries are 60% blocked. That is a piece of metadata that's stored in our system and offered in the pandas data frame for subsequent processing. So then maybe you can go ahead and apply different models to that, or you can do any additional processing you may want to do. You may want to look at more, in a detailed manner, whatever. That makes for a very powerful AI system. We believe that the future is in such powerful data-based AI systems. The models themselves can be relatively straightforward, but the data pre-processing that you do to apply to the models becomes more sophisticated. And we're facilitating that in our system by this metadata mechanism. Chat. I have a question here. Ability to track lineage of data that's required for reasoning, for legal reasons, and also for debugging. Yes, that is correct. We do have the ability to track the lineage of data in our system, starting with the input data, where we annotate that experiment run with the input data spec, which is a snapshot that can always be accessed. It's perpetually available. The next output is basically stored as an MLflow artifact, which is also an unmodifiable artifact that's perpetually available. So even if you have a complex set of processing, every intermediate data and the original input data to that complex set of processing is recorded and available for both legal reasons and debugging. Often you want to go back and see what went wrong with this, and you want to look at the data and say, oh, this step of processing made a mistake. Let's go fix that thing. That sort of debugging is also a normal part of data engineering and data science activity. We support that fully. All right, if there are no more questions, let's wrap this up. Thank you all for attending.